In this video, we're going to take a look at primary storage in computer science. So two things I want to talk about first is the words volatile and non-volatile. So you'll see it a lot, and you'll see questions saying why is RAM volatile and things like that. So what I mean by that is a device that loses data when there's no power. So if you turn your phone off, for example, so say you're playing a game and you're playing Angry Birds or whatever, and you pause your game and then you reset your phone, it doesn't remember where you was at, it doesn't store that data. And if you've got a game where you can save it, then it saves it on a non-volatile storage device. So non-volatile is where it retains that data. So your hard drive, USB stick, anything that you store files on is non-volatile. RAM is always volatile. So primary storage or primary memory is also known as main memory, and this is the memory of your computer system. It's the thing that stores current running programs, and it's what the CPU talks to. It directly accesses all the data in your primary memory. So accessing data from primary memory rather than secondary memory or secondary storage is faster because it's internal. So it uses data buses to get information and put the information back in, whereas when you're accessing a hard drive, it's an input-output operation. It's a lot slower. You can't just use buses, so it takes a lot longer. So just a little thing to think about is that secondary storage, what we did in the previous video, is your long-term storage. Please don't say that it's just a backup. Yes, we can use secondary storage to back up data, but all of your main files, like all your games and music and things you've installed, it's all on secondary storage. So primary is talking about RAM and ROM. Secondary is talking about anything else. So there's two types of primary memory, and they do two completely different things. We've got RAM and ROM. Now the similarities between them is that they're both internal, they can both be accessed directly by the CPU, they use data buses, and they are solid state, which means they don't have any moving parts, like a little chip. Now read-only memory is non-volatile, and it can only be read and not written to. So the program data on the chip is fixed in the factory. So when the motherboard is created with the read-only chip on there, it's programmed there and then. So it means it's permanently stores something that cannot be changed. So it's really, really small as well. So 4 megabytes is the maximum size you're going to get for ROM. And what that does is one specific function. That function is to store the BIOS, which is called the Basic Input-Output System. So this is the boot program, and what it does is it checks all the devices are working. It sort of wakes everything up and says, right, is the hard drive working, is this working, is that working? And it then helps the operating system move from your secondary storage where it's installed into RAM, because your operating system, is always stored in RAM. And this happens as soon as you turn it on and you see the black screen come up and loads of writing comes on. That's what it's doing. It can also be used for firmware, which is a type of program that shouldn't be changed or very unlikely to be changed, and that comes on a component such as a GPU, which tells the computer how that sort of runs. And then it can also be used in an embedded device. So if you've got like an air conditioning unit that doesn't have a computer built into it, it has a little chip with fixed values, how the buttons work, maybe an operating system, but it's a small mini computer almost, and that's stored on the ROM chip. So like a microwave might have that in there, so when you press the numbers it knows what to do. So have a little think, pause the video, question, why not store the BIOS just on the hard drive, and why use ROM at all? So the idea is that a computer, it can't run code directly from a hard drive or secondary storage for that matter. It needs to be actually loaded into RAM, which is what happens in the fetch, decode, execute cycle. Therefore, there needs to be some device to have some code on there that does not need to be loaded, which is your ROM. So the ROM stores the data that allows the motherboard to identify devices. So when the computer first loads, it won't actually have identified that there's a hard drive running. It might be still checking it, so it can't do anything else. It wouldn't work. So you can't take something if you don't know it exists yet. So that chip is on there to get all that initial boot up process going. So the second one is random access memory. So you've probably heard of this one before, and that's RAM. So that is both read and write memory. So it's volatile and loses data if the power is switched off, and RAM can be static or dynamic. The data and processes which are to be executed are kept in RAM, and they are stored there to allow quick access by the CPU. So the main one we're going to see is dynamic RAM, and it's measured in gigabytes. So your computer, like mine, currently has 8 gigabytes of dynamic RAM. The RAM used in embedded systems have a much smaller capacity, so an AC controller isn't going to have 8 gigabytes of RAM, it's going to have like a few megabytes of RAM. So dynamic RAM is built around things called capacitors, which are little caps that you get in electronics. If you Google what one looks like, it doesn't look like much at all. And these capacitors have a bit that's represented by it. So one capacitor equals 1 bit. So a charge capacitor represents a 1, and if it doesn't have a charge, it is 0. So these capacitors only hold charge for a certain amount of time. So if you ever do electronics, you'll see that a capacitor uses to sort of hold a little bit of electricity for a little while. So these need to be refreshed and recharged, So this reduces the speed at which it can work. However, it is cheaper than static RAM, but is much slower. Now, static RAM is built around transistors, where each bit is represented by a circuit of interlinked transistors. Now, static RAM does not lose its charge. However, it is a lot more expensive, it's much faster, but it also doesn't actually use as much energy as RAM. But if you think about a stick of RAM for 4 gigabytes, that can cost you as little as £20 to £30, maybe like $50 for like a stick of RAM, whereas static RAM is a lot more expensive. Now, what RAM does is it stores a program that we're currently on. So what the computer does is the operating system will check that there's enough RAM to actually fit the program in. If there's not, it might say, sorry, you don't have enough memory, it's not going to work. And if there is enough space, it'll copy it from your hard drive into RAM. Now, you'll all have heard of Task Manager before, and this is a piece of system software that comes with Windows. There's similar ones for like Mac and Linux, but I'm going to stick with Windows for now, and it allows us to monitor how much CPU, GPU, network and RAM usage our PC is using. Now, if I just pop onto my screen now, you can see it has a list of all the things currently running. So I'm recording this video, so OBS is currently running and PowerPoint's running, and I've also got an internet browser in the background. I can see that Opera, my browser, is using nearly 1 gigabyte of RAM. My PowerPoint is using just about 500 megabytes, and OBS is using around 350. So what this means is I can see which programs are using what amount of RAM. So this allows us to sort of figure out, say if something's not running very well, you might say, oh actually, why is my browser using so much data when I'm not doing anything on it? So you could say, for example, you can't open a program. Say I want to play a game, I could click Opera, I could end the task, and I'd actually remove it from RAM. So let's do that. So let's end the task. You see I've gone from 60% memory usage down to 50, so it's taken that out of RAM, and now I can do whatever I need to do. You can also go onto your performance, and you can see how much memory is being used. So I've got 8 gigabytes of RAM. Currently, I'm using 4 gigabytes, and then I've got 3.8 available. So that's Task Manager. So the more RAM a device has, the more applications and data can be held at once in working memory. So this makes it appear that the computer is a lot faster. However, that's not actually true. But this is because the computer doesn't have to keep loading and reloading programs into RAM when you're working. It can all be stored in RAM at the same time and switch between, which is a lot faster. So it makes it like your computer is a lot better and a lot faster, but actually it's just because your computer doesn't have to do as much work. Now, this is a problem that is not really that relevant nowadays, but it is a thing. So back in the day, we had not a lot of RAM at all. So we'd be opening programs up and they'd all want to use the RAM so you can use it as normal. However, if two tasks want to use the same amount of RAM and you don't have enough, what they'll both be doing is both be fighting over that piece of RAM they need and not actually doing any work. Now I'm just going to refresh the slide to show you the animation I've got on the screen. So first things first, let's imagine the computer's got 2 gig of RAM. Now both processes want 1.5 gigabytes of memory. So the operating system allocates 1 gigabyte to both, which seems quite fair. However, both the programs can't actually continue until they get the 1.5 they need. So they both just sit there waiting for one of the programs to stop using the RAM, which isn't going to happen. So they're in deadlock and they can't do anything else. They're just going to sit there waiting and your computer's going to freeze up. Now to get around that, we have a thing called virtual memory. So sometimes we don't have enough RAM to run our programs. So to solve this, our operating system can implement something called virtual memory, where we use a portion of our secondary storage, so a bit of our hard drive, and it acts as fake RAM, so virtual memory. And this means our computer can continue to run, however there are downsides. So if you think that RAM's really quick, and our hard drive isn't that quick compared to it, if you're using your hard drive as RAM, then it's going to be a lot slower. So your performance of your computer is reduced. Also, RAM is constantly getting read to and written to. If you think your hard drive's doing that, it's going to be working a lot harder. If you are using it, sometimes you can actually hear your hard drive, like it's almost like a bit of a grinding sound, because it's constantly reading and writing, which is actually almost damaging your hard drive as well. That's a thing called thrashing. Think about secondary storage as well. Think about an SSD. They only have a limited number of read and writes. There's still quite a lot of them, but if you're using your SSD storage with virtual memory, then you're actually wasting your reads and writes on using it as RAM because you haven't got enough RAM in. So that's where you need to upgrade your computer and put some more RAM in if possible. So here's some potential questions you might answer. So you've got, what type of memory is cache memory and why is it used? Why does a computer need both RAM and ROM? What is virtual memory? Why do we use RAM? Why don't we just access the hard drive? And why does increasing RAM improve performance? So that's something you want to look for the video. Make sure you can answer those 5 questions. And hopefully you found that helpful, you enjoyed it, and you subscribe and like, and I'll see you in the next one.